the middle of one of our radio club meetings, and while we're having our radio club meeting, this is the South Kestevan Amateur Radio Society here in Tango Towers private chapel, the postman came and brought this Audioline 341, which I was expecting, and he's from an end user, and it's quite meaningful to him once it's sorting out. And he's told me it works in PA mode and it doesn't light up when it goes into CB mode. So we've dug out our previous repaired power supply. I think that's one that Alan kindly gave us. We did sort it out even though it was relatively new. We'll move the bourbon biscuits, which came from Aldi, other supermarkets available, on a plate that came with an organ, which is Lower Skirko Green United Methodist Free Church. And of course I've got my coffee here, which is in a scratchy corner mug. So I've already taken it out of its original box, as in outer box, and we'll see what we're greeted with in here. So the idea is, it's quite a common thing for these to malfunction in this way. So I thought, while we've got a radio club meeting, and while we've got this radio, even though it's nothing to do with amateur radio, it could still be a useful demonstration. So we're going to power this up straight away. It's even got the correct lead. Wow. And it's even got banana plugs, which will nicely go into our power supply like that. Now the customer says it works in... Am I switched on? No. There we go. Steve switched it on. Thank you very much. So when we switch the radio on, we've got no channel display. If I switch it into public address mode, he tells me it works in public address mode. So we've got no channel display, and as I've said quite a few times before, the capacitors in these sets leave a lot to be desired. So a lot of the CB radios, like the Maxons, we're just not changing any capacitors. They're great sets like the 2000. We're not changing capacitors. Very few on the Cybernet, but the Unidems, whatever they were using, they just haven't stood the test of time. So whenever you get anything using this chassis, so that's the Audioline 341 we're working on, the Realistic TRC 2000 and the Unidem 200, then they use this identical chassis. Now the smaller version, which is the Audioline 340 and the Unidem 100 and the Realistic TRC 2001, use exactly the same electrically chassis. It's the same parts, but they're numbered differently on a different laid out board. We use the Realistic service manual because it's so good to do both types of set, and that service manual does cover both the board variations. We're taking both the lids off because we know we've got to take these capacitors out. So we'll start by taking the bottom lid off, removing the speaker, which is soldered, so we won't be removing the speaker until I bring a smouldering bat, otherwise known as a soldering iron. We may as well take the bottom lid off, and I've no doubt it's pretty pristine. I'm going to sniff this, and it doesn't smell of fags. Isn't that great? I'll pause the video, we'll go and get a soldering iron. So we've got the lid off. So the 4 capacitors. Make sure we're in shot. 470 microfarads. 470 microfarads. As those fail, they're in the audio section, and the very expensive audio IC will be killed, and they're about £18, so you don't want to kill that. So also there we've got 220 microfarads which needs to be changed. That's in the power supply section, and the one that's actually killed the radio will be this one by the phase lock loop, and this is to do with the 5-volt supply which goes to the phase lock loop chip. And viewers will remember that the TC9116, or is it 9? It's 9, isn't it? In these TC9119 from Toshiba has been irreplaceable now for a few years. I was offered some from a firm in Brazil. They wanted me to take 100 at £29 each. I wouldn't even be able to sell them at £29 each. So they are irreplaceable except from scrap sets. And of course the reason these sets get scrapped is because that chip's failed, so that doesn't work out. So what we're going to do is I'm going to unsolder those. We've got some brand new Nikon ones here, and I'll get those plonked in place. So we'll come back in a moment. Right folks, well, I've changed the 4 capacitors and I'll go and get an ESR meter from Mr. Chippy's bench, seeing as he's not looking, and we'll check those in a moment. So just to recap, we've changed that 470 microfarads, 470, 220 microfarads and 220 microfarads, and these are Nikon capacitors, 105 degree rated, not that it gets hot in here, but you never know in a motor car. Was it a sound effect from somebody else? Yes, it was sound effect from one of our members here. So we're going to switch this on and see whether I'm a liar or not. Oh look, we've got a display folks. Show the club members, you see. So now...
Even more amazing, it was on channel 31.
It's on channel, we'll put it on channel 31. So then we're going to do a service, we're going to go over to the workshop. If I plug the mic in, I'm not going to press transmit, if you sent the mic that is. You did. So I've got the original audio line mic as well. I've just hit my head on the lectern. We haven't got a speaker connected, so we're going to just have to plonk the wires on for now. I'm going to turn the squelch down, and hopefully we'll have a hiss from the speaker, if I can actually get the wires anywhere near. We have. So nobody's got a CB, so we can't do a quick thing, but there we are. So the actual repair is now done. Those 4 capacitors, there shouldn't be any others that have played up. And I'm going to go across, we're going to get the ESR meter and we'll have another look from there. I borrowed the ESR meter off Mr. Chippy's bench. So let's connect the first of the 470s, which are in the audio department, and see if they're anywhere near we'd expect. .502 is slightly high and sometimes indicative of failure. Doesn't mean that it will take the voltage that it's rated at. The second of the 470s is, oh that's not, is it? It's 200, that's well down. So that is a problem. The first of the 220s, and I've modelled them up, so I don't know which was in the power supply at the top of the set or the one around the phase lock loop. First one, it won't measure it, it's got a fault. So that's probably the one in the phase lock loop department. And the second one, it's reading 45 microfarads instead of 220. So most of the microfarads have actually bolted, haven't they? Right, so we'll pick up the video from the workshop and we'll leave our radio club meeting and see you later. Right, so that was Saturday, it's now Tuesday. We're going to just skip hangers on, that's seen better days. We're going to skip the Colt 295A from the dealer in Sheffield. He sent another set in, which I think's come today. Because I've half done this, I thought we'll get this out. It's an end user, so I'm going to put it in its case just for now. And hopefully it's now going to just be a matter of a tune-up. These usually work well. You usually get 4 watts. Usually get under 1 microvolt sensitivity. They're never as sensitive as Cybernet sets, but that again doesn't usually affect range. They get less bleed over than most others, probably because they're not as sensitive. So, 13.8 volts, power it up,
So 3 days later, and of course it's still working. So we'll just put it through its paces, jot down the results, and then we'll be able to see whether we've fixed it worse or not. So key it up, switch picture in picture on. We're on the 3 watt scale, we're on channel 20, and it's just 3 watts. If we go to the next scale, it's just under 3 watts. So we'll put down 3 watts. Channel 40, and it is 2.2 watts. And on channel 1 it's 3.5 watts. So hopefully that'll get balanced out. Go back to channel 20, go to low power, and see what low power does on the radio. Right, 1.1. That's bizarre. I think it's had the golden screwdriver at it. And the current consumption is 980 milliamps for the full power. We'll look at the VCO in a moment. Let's look at deviation. This might be lying. Wallow. We'll take that off the other test set, because that says 1. I'll just put in brackets 1. Frequency, you can't adjust it on these. Test set's only been on 5 minutes. Hope it's within. It is within 79. We'll fill that in later. It's probably around about 100. That. So it's heading in the right direction. It's not out of spec. But the crystal has no adjustment on this model. When you key up, what does it say on the meter? The meter's stuck, isn't it? He thought it was, actually. He thought the meter wasn't 100%. It depends if I can do it without taking the set apart, as to whether we do it, etc., etc. Having come from a business radio background where radios don't have meters, to me, it really doesn't matter. But there you go. Let's look at the sensitivity. Unplug the test gear speaker. We actually say, allow a 28-day turnaround, but to be honest, this is probably, when did this come? It came Saturday, so, this is faster than we would normally do, and I say we have jumped a set, because I'd half done it, so I thought we may as well finish it and get it back, and it's quite possible that the trade repair is a difficult repair, and takes a lot of looking into. So receive sensitivity, let's put the signal generator on 2779125. I'll tell you what, I'll put it on 79100 so that it's in line with where the radio is on frequency, if you get that. So we're not tuning it lopsided. Okay, we'll go with the cyanide meter. I'll tell you what, this is working well. You don't normally get this when they're being tuned. 0.455 microvolts. For 10 dB, 0.42. Unless the detector's out, it's all going to go haywire when I when I do the detector, 1.5. Very good. Squelch to full. Let's see where the squelch is. Put this on the attenuator. So at the moment we're at 3 microvolts. 10, 30, 100. I want the radio to open up. Doesn't. It does at where? 2.3 millivolts. Well, at least it opened sometime. So that's been golden screwdrivers, hasn't it? So we'll look at it at the other end. Signal generator to standby. Set the squelch on the radio. Signal generator back on at 0.3 of the microvolts. Nothing. 1.6. Now that would struggle going around Scratchy Corner. So, not good. I can't say where we are on that meter, can I? It's only just sticking. You know, I can... It's just possible if I get a precision screwdriver, but sometimes they're jammed. Just see whether we can. Turn it off a second so I don't short out things. Well, that seems to me that it's unstuck for now. So, let's key up. Go back to the signal generator. So that's now working across its range. Just doing that, you know, just means we can do it with no fee. If we start taking the meter out and the front off, you know, we start going up the next tariff level, so I don't want to do that. Okay, so what did the meter read? There I was faffing about. S9 on this radio. Is not a lot. 18 microvolts, that's a bit generous. And the 3 watt output, when we key up, shows, well, it's supposed to be in the centre of the red zone, so it's actually a bit low. so that might fix itself if we can get the power up. I've gone and put it in the wrong box, haven't I? It's 18 microvolts there, and it is low. Meter lamp works. Let's check public address. It's in nice condition, this, apart from the mic hanger. PA. Checking 1, 2. Oh, it's done with mic gain, isn't it, on these? 1, 2, 1, 2. Is it? Wherever mic gain is. 1, 2, 1, 2, 1, 2, 1, 2. Right. And is it the Unit N100, which doesn't have mic gain, that it's always on full volume? Right, so that's another box we can tick off. So the sockets work. We'll come back to the pots. The only one we've not checked, we've checked high-low power, not checked high-low tone. So let's get it hissing. Yeah, that's fine. I can't remember whether I had that in high or low for that sensitivity check, and it affects the synod reading, so I need to just recheck that. So let's go back to the synod meter. Let's go for 12 dB. Put a bit more volume on. And I'm getting 0.54, 0.55. And that's what I had before, but we've changed the tone to low. We get a better sensitivity of 0.47 because we've lost some of the noise. So we'll tune it in the high position so that it's a fair reading. I'm just pushed for time at the moment, so we're going to do the VCO. But I'm not going to do it at this moment. Let's see if we can get on with the transmitter tuning. It's had the golden screwdriver in the VCO. Noisy mic switch. Said we don't repair mics. Could do with some service all in there. We could repair mics, but it'd be the same tariff as repairing a radio, so it would be stupidly expensive. The radio is very cheap, but because we're not retail and we're trade, I expect dealers to sort mics out. And people who approach me for repairs as an end user, most of the time I'm expecting them to be able to take 3 screws out of the mic and put some switch cleaner in. Right. Going to transmit, turn the racket down, put a different meter up on the screen. There we go. Make sure we're still on channel 20. We are. We're at 13.8 volts, just need to check that. We've got the bottom on because it can have a capacitive effect. And let's go for it. So we're at 3.5 watts. I think that's a transmit one of these. It may not be. It is a transmit one, yeah. Without getting the manual out. Yes, we're now at 4 watts. So we'll still carry on with the procedure there, and the procedure is this one, one's peaking. That looks right. and then you set 4 watts with that one, but we're at 4 watts, so that's fine. So if it's within 0.1 across the 40 channels, we've cracked it. There's channel 40. Yeah, no, it's 3.1 watts, and channel 1 is 4.1 watts, so something needs a bit more twiddle. Let's get a definite peak and a trough on this one. That's definitely a drop, that's definitely a peak. Look at that. Channel 40. Which one's affecting this? It's not that. We haven't had the coil stretcher in here, have we? Try that. So now we've got 3.9 watts on channel 1 and 3.8 watts on channel 40. Let's see if we can just bring that up a fraction. I don't think so. So it's a matter of, you could get 4 watts out of the set, but on one channel only, and then all the rest of the channels will be, you know, like 3.1 or something like that. These coils are an exact placement. I just need to check. Yeah, you know, there we go. That's 3.9 watts on channel 40. 3.9 watts on channel 1. 4 watts on channel 20. So just check one more coil placement. You could say that was 4.0 something, but really only just over. And the set's hot, that's 3.9. And that's 3.9, so... And of course the set is hot, so when we come back to it, so I think that's a good setup. And remember, my test set reads 0.4 lower than anybody else's because of the way it's selected, so it's only reading what's on the actual frequency which we want. And not bundling it all like most meters will. So it's in bands, and it's looking at, we've said this before, what is it looking at? I think it's 24 to 33 megs, to be honest. Right, so the meter, tell you what, we'll do low power. So, banging across on low power. It's now 1.5 watts. And there we are, reset to 400 milliwatts. And we'll just check what the current consumption now is. You know what, it's only 952 milliamps. And we're doing more power. So it was 980 milliamps for 3 watts, now it's 952 milliamps for 4 watts. Which goes how to show the interstage SWR is so much better. Tell you what, we'll look at the S meter for transmit. See whether we can rear it up so we can all see this. Hopefully I put you on channel 20, wouldn't it? I have to recheck 400 milliwatts now, aren't I? Let's transmit. I thought it was. What's that say then? Oh, it's receive, isn't it? So I want it in this. Why isn't that doing anything either? That's squelch. Wait till you get to my age. Need your glasses. RF meter, we'll start again, is the one at the back. We're in the centre of the red zone, which is where I want it. Just check the low power once again. It needs resetting. Because it's now 320 milliwatts, and we want 400 milliwatts. Just like that. And we'll go for deviation, and I need to disappear. So on this test set, now things have warmed up, make sure the mic gain's at full because we've messed with PA. Wallow. It's 1.5 kilohertz. So we'll go on. The test set behind me, as I say, I can't always trust this one. To do with the capacitors changing in the deviation meter part of it. But no time to do that. And now we'll look at the on the test set behind me. Wow, you know, it's the same, it's 1.5. So I'll set it on the other, so we're probably not playing up today. Wow. Wow, it's still low, that. Wow. Strange if it needs that much adjustment. The reason we don't use the quartz lock 282A test set for CBs, and it's on the bench behind, is it doesn't go under 88 megs. So on receive. So the signal generator is VHF only and UHF. So, but all the transmitter functions will work right down to 10 megs. Right, let's have a look at deviation now on the Marconi. Wallow. Could be a little bit over. So we've obviously got the Marconi working right today. Wallow. There we go. So 2.2. So it was 1.6. It's now 2.2 to 2.5 kilohertz. Normally, you end up with this being set ridiculously high, don't you, when the golden screwdriver gets to it. But that's not been the case. So when I come back, we'll do the VCO. I'll have to get the realistic service out for that. So we'll see you in a bit. Okay, so we're back on this. Let's see I'll take picture in picture off. We'll do the VCO. And let's see if we can get that in the picture. Right. So I've just printed off the relevant pages from the realistic service manual. So we'll just pop this on. and we'll do the alignment at test point 1 for 3.5 volts on channel 40. So that's selected channel 40. I can't remember whether these are floating chassis or whether it's earth. So we'll just check that. So it's not a floating chassis, so we can just put the prod for negative on an earth point. I can never remember. And then test point 1. I don't see enough of these to remember. But I know one thing, I'm going to need the other glasses. So the 2000 is equivalent to this model, and 2001 is equivalent to the smaller model. Different boards. Test point 1 is resistor 52, and it is on the small one as well. And if you can find that on the board, it says test point 1, and I will zoom in on that. So, test point 1, you've got capacitor there, in between you've got resistor 52, and there's no paint on this leg of that resistor, so it becomes the test point. So, I'll put the prod on there, I'll tell you what I get. I've got 2.8 volts, and then we'll zoom out the camera to its normal position. So what does it need to be? I've already forgotten. 3.5. So it's actually okay. So well, hang on, we're in receive, aren't we? It's going to transmit. Wow, it's well out. So 4.8. So it needs to go down to 3.5. Okay, so that was worth checking. So I'm just going to check it on channel 1. It doesn't tell you to do this, but we're going to have a kind of lock range, and that's going to be, you know, that kind of looks right on receive, that kind of looks right on transmit, and on channel 40 again, that's receive, that's transmit. Now, what they then have you do is set this with onto test point 2 with an oscilloscope and do this for maximum. We've done that before, but because this set's already working, we don't need to do that stage. If we were setting it up from scratch and there was no transmit and no receive, then you start having to follow it exactly. But we don't need to do that, because what we're going to do is we're going to set that with the synad meter, and then we know it's getting the greatest signal. Now, I've already said this radio is doing 0.42 microvolts for 10 dB synad. So I printed off the spec, and if we look at the receiver spec, oh, I'm not printing it out, what a wally. I think it said better than 1, so we're well better than that. So they want the radio to be between 3.4 and 4 watts. That's your pass mark. Right, so that's that done. So we'll move on to the receiver. I'll tell you what, we'll do the frequency now, because the radio has, of course, I've had a break, I've had lunch as well. It's doing now. Yeah, 27.7, I'll put it on channel 40. 27.79106, that's the truth. What was it, 4.5 volts, and it should be 3.5 volts, that's done. So you can't adjust it. Right. So now we'll move on to the receiver. So I'm going to set the signal generator 79 107. You can see why I'm doing this. So it's because the radio is not quite on frequency. I don't want the signal generator to be quite on frequency, so that we tune the receiver accurately. Neither here nor there, this frequency thing, but I don't want this receiver to be lopsided. We're going to start with the detector. There's the oscilloscope. And we'll put 100 microvolts on. And that's what we've got. So, which is the detector coil? Can't remember. It's going to be that one, isn't it? There's the Clever FM chip. Who's already spot on, no adjustment needed. So now we'll go over to the sine meter and we'll start with the what's known as the front end of the radio. So I want 4 dB. So we've got a weak signal and not saturating the receiver, because FM receivers have that capture effect. Spot on, no adjustment needed. Spot on, no adjustment needed. Spot on, no adjustment needed. Spot on. Now we'll do these IS. Put a bigger signal on for that. Little bit on that one. There we are, that's it. Whether or not that's made any difference or whether we've fixed it worse is another matter. So we're actually at 12 dB there, and it's now spot on 0.5 microvolts. For 10 dB, it's now 0.42, which it was before. And for 20 dB, it does it. It's now 1.4 microvolts. So whatever we've done, we've got a little bit less noise. Now if we look at 12 dB again and put the tone in the low position, you can see we now have 0.42 of a microvolt, and for 10 dB we've got 0.35 microvolts, and for 20 dB we've got 1 microvolt. So that's the difference the tone makes. But it's down to noise. It doesn't make it any actually more sensitive. Squelch. Now I messed this up, didn't I? First of all, we'll do 100 microvolts so we can align the S meter. So the signal meter's there. That's now where we want it to be. I think we did the RF. We did do the RF meter. Just out of interest, what's the power now? Spot on 4. Squelch. So squelch to full. Signal generator to 100 microvolts. Let's look at the attenuator. So we're at 10, 30, 100. I now want to adjust that until the radio squelch opens, which is there. Back off the attenuator, 30 microvolts, back to 100, it opens at 100. So now let's see, fill that one in. This needed to get better. That really wants to be under 1. Let's see if we've done that. So set the squelch on the radio, signal generator to 0.3 of a microvolt, nearly came in. Let's see. It's 0.68. So that's fixed that. Microphone is working, potentiometers are working. There we are, we're done. Right, I'll go and get the lids back. Never know which... although polarity doesn't matter with the speaker, perhaps I've got one of those OCD illnesses. Which one's going to chassis? Not that one. That one. So that one I'm going to put a yellow crocodile clip on it. So when I come back with the speaker, which is in the other workshop, since we took it apart in the chapel, I'll know which one is which. Right. So here's the plate we had the biscuits on. United Methodist Free Church of Skircote Green, 1881. Our Conacher organ came from there, and the minister gave us these couple of these plates as mementos, seeing as the church was being demolished. So notice the correct speaker is 16 ohms. So 8 ohms you could end up overloading the amplifier very easily. Just a point. I think we need a bit of solder on there, they look a bit dry. So let's hope his speaker works. So this radio exceeds the manufacturer's specification. It's always nice when 40 years later it can do that. And just remember, a lot of these older sets outperform current models. So it's silver screws in these, and I've never found a supplier. So these Midland Precision series with the silver screws, we have to look after the screws. So we ought to apologise to the Colt 295A, which didn't get looked at today and was scheduled to get done today. Supposed to be doing some Tate 2000 business radios for amateur radio use, but it just keeps raining and they're in the shed. I have a garage sized shed, so I don't want you to think it's a 4x4 foot little shed, and it's got proper steel shelves in there. And that's where a lot of the tat is. And some nice stuff which wants restoring, like some Heathkit stuff. I've got a DX40 in there, and I've got a DX60 in there. Perhaps I'll do those in my retirement in about 4 years. Many years ago I ran a mobile disco. You know, I collect records, about 19,000 vinyl singles, and there's a good reason to be able to put records through the account books. I thought, well, we'll run a mobile disco, which I did, and so anyway, I'd been in my 20s at the time, and this couple booked me for their husband's retirement. So it was on a Friday night. He'd finished work that day. He worked at the council, and he finished work, and we had this disco starting about I think it was 7 o'clock, just till 11 or something like that. And you know, it was great. Played some of his favourite records. Everybody had a good time, and he died on the Monday. And it, you know, you get to that 65. It was then. It's a bit more now. It's such a shame. Right. Well, we're done. Make sure it still works. Just get me talkie-walkie. 1 2 1 2 1 2. 1 2 1. Oh, helps if this is 1 2 1 2 1 2 1 2. Right. Home speaker. Take the signal generator off. Soldering iron off. Squelch on. And find the lead from the base station area, which I keep telling you is an Antron 99. We've just put up a gain master on the Midland base. We'll have a video for that when we've done it. So, are we going to hear anything? 1 on a Roger. A Roger. No, we're not going to hear anything. Well, that's worked out really nicely. And we'll do an on-the-air test later on. So I hope you enjoyed that, and thanks for watching.